Hello everybody and welcome. This is a video summary of the Malware Analysis chapter, so let us dive right into it. Malware is made up of two words, malicious and software. Basically, it's software that does bad things to our computing devices. In a more formal definition, it is software designed to harm or secretly access a computer system without the owner's knowledge or consent. Malware has many types, but the average person calls it a virus. If you're not a security person, then fine. Call everything a virus, not a problem. However, for us security professionals, we really need to know the different types, their behaviors, their attributes, how they infect, what they infect, and so on. So there will be a difference, and we have to know that difference. Hackers use malware to destroy or corrupt data, to steal our private data and information, even steal our money. Sometimes they use it to shut down a network system, and so on and so forth. Hackers use malware as cyber weapons to launch attacks against either standalone computing devices, such as our computers, our mobile phones, or against an entire network. It goes without saying that attacking network infrastructure and services may have a devastating impact on organizations. A network attack, however, may originate by attacking an individual computer on that network. So let's say you're a college student and the malware infects your own laptop. However, when you go to the college and you join that network, that malware may spread and affect the entire network. In most cases, our computers get infected by viruses because of some things we do and some things we do not. Most malware incidents involve a human action, which is mainly due to a lack of awareness. Actions like what? Well, like clicking unknown links, downloading and opening attachments, jailbreaking or rooting our phones, not having an antivirus, not updating our antivirus, and so on. Before we get into the different types of malware, let us examine how we categorize them. One way is to look at what the malware infects on our devices. Is it the system or the boot sector? Is it files or specific file types? Or is it a combination of those? So for instance, you might say this is a file virus, meaning a virus that infects a file. Another way is to look into how they infect. In other words, what is it that the malware is doing on our computers or to our files? A malware may, for example, overwrite the contents of a file, like a cavity virus. Another malware might change the extensions of our files. So for example, from .doc to .pdf. And of course, there are the more dangerous malware that may disable our interception programs to evade detection, like tunneling malware. These are some examples. A macro virus, as you can see here, infects files that support macro programming. And I just talked about the one in the middle, the cavity virus. And finally, the sparse infector virus infects occasionally, meaning not every time. So maybe every other time, maybe every 5 runs, or on a specific date. Let us talk about the well-known malware types. A virus attaches itself to a program. In other words, it needs a host. and often requires a human interaction, for instance, a click. A worm, on the other hand, does not attach itself to another program, and it replicates and propagates, spreads itself without a host and without human interaction. So it is more dangerous than a virus. A Trojan horse or a Trojan disguises itself as a useful program, but it includes within it some malicious script, which we call the payload. The payload can be any type of virus. One example is a rat or a remote access Trojan. A rat opens a covert channels that transfers data without our knowledge. Spyware is a type of malware that collects and sends private information like passwords, PIN number, financial data, and so on. So it collects it from our computer and sends it to the hacker. One example of spyware is what we call keyloggers, which register each keystroke entered by us on our keyboard. And a keylogger can be either software or hardware. Adware is a type of malware that displays ads without our permission. They often spy on us as well, so it can be a combination of spyware and adware together. This is an easy way to display active connections. I talked about remote access Trojans. I talked about covert channels. So one way to detect whether you have one of those is to use this command and to see what established connections are there. The following are considered more advanced type of malware. Ransomware is a special type of malware. It can infect the system via a worm or a Trojan or another technique. What's special about ransomware is that it holds the victim's computer or files for ransom, and the hacker would then blackmail the victim to pay money. Rootkit is a malware that attempts to conceal the existence of that payload in the victim's host computer. Of course, this is to avoid detection. Rootkits do so by modifying the host's operating system so that the malware is hidden. And by the way, the term rootkit comes from gaining root access in Unix Linux system. Finally, a backdoor is a malware that allows bypassing normal authentication procedures and therefore giving the attacker access to the system in the future. Again, backdoors may be installed by Trojan horses, worms, or other methods. I always say it's a game of cat and mouse between malware creators and antivirus systems. The game is simple. Malware wants to go undetected. Antivirus solutions want to detect malware and know that there is something wrong with this file, for instance. To avoid detections, hackers use evasion techniques. To counter evasion, antivirus companies perform what we call malware analysis. Hackers continue to develop advanced malware all the time. Malware code can be processed to hide its signature and evade detection using different techniques. One, for instance, is to encrypt the code or to compress it. Some hackers may use code to obfuscate or hide its signature. One common technique we used in the Trojan lab activity, if you recall, was encoding. Encoding, by definition, is the process of converting some data from one form into another. We use it sometimes for standardization. It is a way of representing something in a standard way. Sometimes it is just text characters. A hacker, for instance, may hide a virus by converting it from its original binary form into some sort of an encoding such as base 64. This is an example of base 64. What you see on top is JavaScript, and what you see on bottom is the encoded version of that script. As you can see, the encoded version is nothing but text and numbers, meaning it doesn't have special characters that are considered risky and dangerous. What you're looking at here are the stages of a virus's life. In order to detect number 4 and 5, security professionals must understand what the virus does and how it works. Therefore, we perform what we call malware analysis. Malware analysis, by definition, is the study of the functionality, origin, and potential impact of a given malware. There are two types of malware analysis. Static analysis is the process of analyzing a binary without executing it. First of all, static analysis does not require running the malware, and that's a good thing in terms of security. And the second thing, it examines the file for signs of malicious intent based on technical indicators like the file name, the file type, the hashes, strings like IP addresses, for example, domains, and so on. Dynamic analysis, on the other hand, is the process of executing the binary in an isolated environment and then monitoring its behavior. So again, in static, we don't run it. In dynamic, we do run it. However, we must run the malicious code in a safe environment that we call a sandbox. Dynamic analysis provides deeper analysis by watching the malware in action. So you get to see it. And it eliminates the time that it would take us to reverse engineer a file based on its code, meaning what we do in static analysis. There is a big challenge that hackers are always creating a new and advanced malware. There is no foolproof prevention method. However, we must employ defenses in depth using multiple countermeasures. Awareness, education. You need to use an antivirus. I find it very surprising that people would pay thousands of dollars for a computer or a device, but they're not willing to pay small amounts to protect that investment. Of course, in an organization, we may use enterprise antivirus. We may also employ firewalls and intrusion prevention systems. And whenever you have devices, you need to ensure that their security configuration is at the hardest level. And finally, when we cannot prevent, we must have detection and response measures in place. So intrusion detection system and of course an incident response plan. Before we conclude, earlier I mentioned network attacks, which typically target network services and infrastructure. The following are 4 examples of such attacks. Number 1, denial of service, which is an attack that attempts to prevent legitimate users from accessing network resources. Distributed denial of service is a special type of DOS or DOS where a host is targeted from multiple servers or workstations. Another common attack type is to attempt to steal an entire session from a client. This is known as session hijacking. Number 3, the ping of death. In this attack, the attackers attempt to choke a service by sending it a large ICMP or ping packet that the service cannot handle. And finally, a buffer overflow attack targets a vulnerability in poorly written code. Let's say a programmer writes a program, but he or she does not check for the amount of memory space in use. Therefore, when data is entered, this may create what we call an overflow. This is it for this video. I hope you enjoyed it. I will see you in the next one. If you did enjoy it, you know what to do. Thank you for watching.